Welcome everyone. If you've been following this spontaneous CNC build, you can see that in my last two videos I assembled the Y-axis and the Z-axis. Now in this video I'm going to do some designing in CATIA. I'm trying to figure out from what metal I've got how I'm going to use that and what sizes I'm going to cut that. And also in this video I'm going to create the drive system and probably model up all the gears and the pulleys so I can get the right size, because I really don't know how I'm going to mount that onto the vertical axis. Now something, I'm going to put a video on here you can see. Now in CAD it's rather difficult to get the scale. I've worked in CAD for 18 years or so, and things always are a lot bigger than you expect, even though you're working on them for hours and hours, or they're a lot smaller than you expect. And so it's a really good idea to just mock up the parts you've got and really get a good idea of the scale of things, and that's what I'm doing here really. And one of the things this told me is that my vertical axis is far too big. So what I decided to do, and you could see just then in my CAD program, I'm actually splitting my vertical supports and I'm going to use two of them. So that's from building that mock-up very quickly. It only took me 10-15 minutes. I took everything I had, got a really good overview of the size of everything, and now I'm going to go back into CATIA and change my design on that vertical support. Also I'm going to model up the pulley system, so let's get involved in that. So here I'm just positioning the support, the vertical supports, which I've now cut in two, so I'm going to have two of those, twice the width. I don't know if they're going to be the same height yet, we'll figure that out. So I'm sliding these together, I'm putting some wheels in there, I've got the stepper motor in there. I'm just seeing what kind of width I'll need. Obviously I'll have some kind of mounting plate across there, but really don't know what yet. This is what the CAD's really good for. You can just throw your ideas in there and see how that's going to work. Got all the sizes in there. Everything's modeled pretty exact, definitely within a few millimeters, so it should be pretty close. Now I'm moving I'm just duplicating the stepper assembly that I have and just moving that down, because a lot of the parts that I'd already made for one of the other axes I didn't have, and it's a lot quicker just to move the whole assembly over rather than move all the individual items like that. And now moving on to just quickly designing the gear pulley, I guess you'd call it. The belt will wrap around this. I'll have an upper and lower belt, which I'll model in a moment. So this fits on the end of the stepper and it'll fit exactly aligned where the groove is in the horizontal beam, and then the belt will fit in that beam. So I'll quickly model this and then I'll model the belts in there just to make sure everything's the right size and what kind of offset we're going to. And very similar component is the pulley themselves. So I've actually just used the gear model and just delete the teeth and just change the diameters a little bit, and voila, we end up with a pulley. And then move on to modeling the belt, and this is a GT3 belt because the teeth are 3mm as apart, and it's going to be a 1.5 meter run, which sounds like it'd be a lot of modeling, but basically you just have to model a part of the section and then just instance it along the 1500mm. On the screen. This is just a 2D sketch in CATIA, so you create this on a plane, and then in the 3D workspace you can just use those sketches to pad them out, or you can put them along different shapes to make more complicated shapes, or revolve them around axes, much like any other CAD or visualization. And now I started on the drive belt. Actually the lower belt is only going to be for grip of the upper belt, so rather than the belt being allowed to stretch over the full 1.5 meters, it's going to get pushed down by the wheels and it's going to grip into the lower belt, so it's only going to stretch over the 4 or 5 inches that it runs through the drive system. So I just created a rough profile and then elongated that belt shape around just to get a good idea, and it's nice visual when I render it up. I really like that side of it. And here we can see me just dropping that little assembly into the visualization package and adding a few textures, just try and get a nice photographic image. Bit of eye candy is always rewarding. I'll show you the pictures of the output of that right now. This does a really good result. I think it's Keyshot. Does some good results pretty quickly. Gives you some nice photographic ray trace renders. Now moving on to just putting the wheels, I think I'm going to have on the bottom just to stop the whole thing lifting, tilting over. I may also have a lower crossbeam that joins them together underneath. That'll give it a good box section and stiffness. Still not. And now on to creating a plate on the inside. So I'm going to basically box in the horizontal beam. So I'm going to, you think of all those wheels, pulleys are basically on levers. So they're a screw. Their axis is a screw just sticking out, and it's got the wheel on the end of it, or almost the end of it. So it's bending quite a lot. So if we put a plate on the other side too, and tighten that all up so the axis is nice and tight through, improve the strength of that whole area quite a lot. Now something I also thought with this is because I've not got the ability to machine anything yet, I really don't want to spend too much money. I'm just going to do one of these sides with polycarbonate, and I'm going to get probably 1/4 inch polycarbonate. It's quite cheap, really easy to drill. I can create a drawing in this tool just to print a template out in paper or cardboard, and then I'd be able to drill and cut that myself. So you can see the drawing here that I created of all that. So this will give me a really good template for drilling all those holes in the polycarbonate. Now I'll probably use polycarbonate. I think it'd be really cool on the inside because you'll be able to see this belt mechanism moving with the wheels, and that'd be really nice. But if it's not strong enough, then I can use the machine to, to create a steel plate or something in there. That's a great thing with these machines. You can always upgrade and upgrade later. So kind of keep on the budget side now, but the transparent polycarbonate. So now I'm looking at the X, which is the upper gantry, and you can see I've actually got a spare, I think it's an 8060 extrusion. So that's going to be higher up. It's going to be a reaction beam basically. So if you can imagine the Z-axis is your only axis that's a lever. So when it's drilling into hard wood or even aluminium, it's pushing, and it's the longer it is from the actual drive mechanism on the X is basically a levering force. So that's multiplying that force, whatever it is. Now having a beam above that, it would actually be an reaction beam. So in the higher it is, the better it is, because you got that leverage force as well acting the other way. So my idea is if I can make one of the vertical beams as long as possible, if one can be a little bit shorter, I can spread that out. Obviously you've got to be careful because you've only got so much movement between the two beams and your Z-axis. So the higher that gets, the less movement in your Z-axis get, which means the less height your part can be in the Z direction. So it's all compromise really, but having the strength is definitely a priority. And back to the eye candy here. So I thought I'd render this up and try and make it look a bit polycarbonate on that inside plate, so you can see what my crazy idea was there. And also I thought for the support plate between the vertical extrusions, you can see, make that polycarbonate too. So you'll be able to see from the outside all the mechanisms. And this polycarbonate is actually quite strong using it like that. I mean, you don't want to use it like in bending. You don't want it levering out anywhere with weight on the end or creating a support like that. But just in this kind of scenario where you've got a lot of fasteners in a very small area, it's pretty good. But it's not good enough in the long term. I can always switch it out for metal, but it will look pretty good. Most of the session I started looking at the hardware, so the screws, the bolts, the spacers, the eccentric washers that will be on the bottom, and quite time consuming. I would recommend, if you're going to buy things like fasteners, if you're going to need quite a few of the same ones, get onto McMaster and Carr. Absolutely brilliant website. It's a bit expensive for some things, but if you're just looking for good quality screws and nuts and washers and spacers, you really can't beat them. I mean, definitely check the prices. Don't see the first one and see it's too expensive, because some fasteners hardware are very expensive for some reason. Maybe because it's their tensile strength fasteners rather than shear, or vice versa, various materials. So you can get the cheapest one. You can probably get 100 for like 10, 11 bucks, where you may pay far more than that buying these in like 25 packs. And generally, I know some of the suppliers that are selling some of these, they're really crappy material. And if you buy the good quality steel fasteners, you'll never you'll never mess the threads up as easy. You'll be able to take them in and out as many times as you want. Definitely worth investing in buying them in higher quantities, I think. So pretty much filled all the hardware in this mechanism I need. Luckily it's going to be a mirror on the other side, so I can just copy the whole assembly and flip it around and just place it where it needs to be. I don't have to do this all again. And it does look quite nice in the renders. And with this tool I can also print out a BOM list, so I can see exactly how many of each item I'm using, so I can quickly have a peek to make sure that even if I've ordered 100, may not be enough, so I might have to order 2 packs. But and then I just kind of render it all up. So I hope you enjoyed this little design session. This is basically what I go through. This is a lot more of the work actually placing all this hardware and stuff than actually modeling a lot of this stuff up. It's because it's the extrusions are really easy to model. Moving stuff around is really fast in these tools, so playing with your ideas. The plates are really simple to model, so the actual time consumed is placing spacers and where things are going to be. If they're too small, you have to change it out. So anyway, yeah, the next one I might be back in the real world assembling something, or I might be in CATIA playing with design still. I've really not cut any metal yet, and I don't want it to until I'm sure. I have ordered a shaft, so I'm gonna place extra support on my x-axis with a shaft and maybe linear bearing. That's one of my ideas. I want that to be really really strong. And then obviously you saw I've got that 60-20 anti-reaction beam there, anti-reaction beam and that reaction beam. So yeah, I hope you enjoyed this. Love to hear people's comments, what they think of what I've been coming up with. Any suggestions would be awesome. See you in the next one. Bye bye.
Jerky. Whammo! First, jerky.